Very good morning, students. Welcome to IIT NEET Foundation, our Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So once again, I welcome all the class 6th students for today's session. As you can see on the screen, and you are well aware, my subject is so there is some technical issue. My subject is physics. We are in class 6th. Our ongoing chapter number 7, electricity. So today we are entering into the session number 3. So far we completed 2 sessions in understanding the concept of electricity. So we'll continue where we left in the last class. But before that, let us recall what we learned in the earlier 2 sessions. So first of all, I explained you about the history of electricity, right? When this electricity started around 2000 years back by the great Greek philosopher Thales, who first introduced the word electricity by observing when two different bodies rubbed with each other, both the bodies are started attracting each other or attracting some light objects like dry leaves, papers and all. So from that observations, he concluded that there are two charges. One is positive, other is negative. Because of rubbing, they are getting charges. So that electricity is named as frictional electricity. First one, starting. Then the studies are continued further by various scientists, starting from 600 BC to till date. It may be Gilbert or it may be Ampere. So many scientists start continuing the study of Thales, and so many things are observed during the electricity. So when you see in the classes, we discussed about the various components of electricity. We discussed about what is cell, what is bulb, right? What is switch, and what is introduction to the circuit, electric circuit. So as I have already told, electric circuit must contain one source of electricity, which is either cell or battery. Source is nothing but the component which gives electricity is called source. It may be cell, it may be battery, it may be generator, it may be inverter, it may be a transformer, right? Bulb is a consumer which utilizes electricity. Bulb or fan or fridge, TV, AC, geyser, grinder, all these are the consumers of electricity. Of course, the switch or key, very important to control off on. To make the circuit or break the circuit, switch is used. When these three are connected through a wire or a cable, and that is called electric circuit. In every household, if you see all our electrical appliances in a household, either it is a TV or a computers or a AC or a fan or tube light, refrigerator, geyser, all these are connected through cable only. We cannot see the cable outside because it is concealed inside the wall only through a plastic pipes. So like that, all these electrons are connected through a cable. So that's called the circuit. Means all the electrical appliances are connected through a cable called an electric circuit. Right? So every electric circuit, minimum requirement is one source, one consumer, and one switch. Very, very important, these three. Extra anything may be there. Extra any number may be there. You may have 100 sources, you may have 1,000 switches, you may have 500 consumers. But minimum one required for the construction of electric circuit. So we discussed what is electric cell. So when number of cells are connected, it is called as a battery. Then we already discussed what are the conductors, insulators, all the materials which are available, how they behave in the electric field, whether they are allowing the electricity to pass through them or whether they are stopping. You take one copper wire, you take one rubber. Copper wire allows the electricity, whereas rubber does not allow. If you take any wire, inside copper is there, outside is covered with the rubber. Why? To avoid the shock. So based on that, whether they are allowing the electricity or not, they are classified into conductors, semiconductors, and even I told one more, that is insulators, right? Then earthing also we discussed. Earthing is a very important phenomena to avoid the shocking. To avoid the shock by the electrical appliances, all the main, from main meter, will take the wire and will earth. Which is called earthing. Then we have seen electric circuit. Okay. So this is electric circuit, how they are related. So a circuit is represented by some symbols. Okay, for example, if say we have source. So what is source here? Source is a cell. So more than one cell is called battery. Longer one is positive, negative, positive, negative. We connected the source here. Source is connected to, for example, bulb. The symbol for bulb is this. Then we have a symbol for key or switch. They are connected through wire. So 4 are there. 1 is source, 2 is consumer, 3 is key, and 4th one is wire. And this is a simple diagrammatical representation of a simple electric circuit, which should contain one source, one consumer, one switch, and connected through a wire. Right? So every household, domestic or commercial, wherever you go, all the electrical appliances are connected in this way only. If any one of this is missing, it is not a circuit. No switch, we cannot control the current. No source, we cannot supply the current. No consumer, we cannot use the current. No wire, we cannot connect them. Right? Such a wonderful diagrammatic representation of the electric circuit. Okay. Right. So some more information we'll discuss in the today's class. As you can see here, some common types are toggle switch. Switches are used in our houses. Push button switch. There are so many types of switches are there. So many types of switches we can find. And used in the starter of the water pump. For water pump, we use one kind of switch. For fans, we can use one kind of pump. When you go to industries, we can find a big twaddle switches. So many types of switches are there. Right? Now, the next one is, after knowing about the electric components or like cells, bulb, and switch, we can use the electric resistance. Another important term. Resistance. So what is resistance? Name itself indicates which stops, which controls the flow of electron. Whenever current comes more, high voltage you can call, to control the flow of electricity, we'll use the resistance. Resistance is the property. It is a property of material. Property of material. It may be copper, iron, or a silver, whatever it may be. Different materials will have different way of resistance. So resistance symbol, represent like this. This is a symbol of resistance. Just like a speed breaker. Why you do speed breakers? You see in front of your schools, in generally, in front of schools or college, you can find speed breakers. Why? Whenever a vehicle is coming great speed, to reduce the speed, to control the speed, we'll use the speed breakers. Similarly, to control the flow of electrons, we'll use the resistance. Is a symbol of resistance. The property of material to control the flow of electrons. Symbolically represented by like this. And units are ohm, name of the scientist. It is measured in ohm. The symbol of ohm is this. So the standard unit of resistance is ohm. See, if an electric bulb is provided a small coiled thin wire of tungsten which is connected to two terminals of brass. When the terminals of the bulb are connected to dry cell through wires of the copper, the bulb is started glowing. If you observe carefully, you will notice that it is the thin wire of tungsten which gets white hot and emits the light and not the brass terminals. Why does the thin wire of tungsten get hot and not brass terminal on the connecting copper wires? So if you observe closely the bulb, we can find the terminals in the form of a design which becomes hot, that is tungsten filament. They are connected to some thin wire, copper wire also. But when we are passing current, we observe from outside, the filament will become red in color and gives out the light. That is called heating effects of electric current. But it is called heating effects. So the filament is called, the tungsten is called heating element. Okay. So different electric appliances have different elements. It is because tungsten wire offers friction to the passing of electricity. Friction. What is friction? That is resistance. Thus, electric work done is overcoming the friction. Hence, electric energy changes into heat energy and light energy. The friction offered to the passage of electric current by a material is called resistance of the material. So, the friction is nothing but opposition. So, opposition offered by a material. So, tungsten offers more resistance compared to the copper. Right? That is called as a resistance. Resistance is the property and the material which is showing that property is called resistor. Right? The tungsten is called resistor and the property of tungsten is called resistance. Right? Clear? So, resistance is nothing but the friction offered by the material or which controls of the material which controls the flow of electron is called the, right? See here, from some information, from resistance, it is implied that given material will conduct electric current, but will also obstruction like passage. If in no way will a friction or resistance make material non-conducting, they cannot make, they cannot completely stop. If they can stop, what we can call it as a insulator. They just resist. They just offers the brake. So speed breakers cannot stop the vehicle. It makes the vehicle to reduce the speed. Right? See here. There are 1, 2, 3 are given. 3 diagrams. One is a single bulb. Second one, there are 2 bulbs. Third one, there are 3 bulbs. Made observation. Shows a single bulb connected to dry cell through a switch. When the circuit is closed, the bulb glow brightly. Closed means switch on. When you switch on the circuit, very bright you can get when there is single bulb. So second case you can see. Shows the 2 bulbs connected to dry cell such that the second end of one bulb is connected to first end of the other bulb here. End to end connection. This is the second end. This is the first end, second end. This is the first end. Second end is connected to first end. Right? And what happened in such case? Bulb connected to the first end, another bulb. When circuit is closed, 3 bulbs glows, but very dimly. Whether it is 2 or 3, one bulb is there, it comes very bright. When you connect the another bulb, that is called end-to-end connection, which is called series connection, bulb will become dim. When 3 are there, still dim. Right? So furthermore, if the circuit is broken at any one point, suppose if you broke the circuit here, current won't flow in a second. Suppose you break here, current will flow for 2 bulbs, it won't go to the third bulb because it's broken. Once broken, suppose you can see decorative bulbs in your house generally will use for all the festivals. Decorative bulbs. Diwali or even Christmas also, they'll use the bulbs. Series bulbs they are called. Means one bulb is end to end. In such case, what is the disadvantage is, when you disconnect one bulb, one wire, the current won't flow in the other direction. Only up to that only current will flow. Further it won't flow. Because they are connected end to end. Such connection is called series connection. What is called? Series connections. So, to increase the resistance, we can connect resistors either in series or in parallel also. So, before going for that, I'll show you one video, basic video on electricity. Then we'll move to the characteristics of resistance, right?
And circuits. Class 6, Science. In this lesson, we will learn about sources of electricity, electric cell, electric bulb, electric circuit,
What we learned
circuit diagram and symbols, electric torch, conductors and insulators,
we learned already.
and electrical safety.
So all these we learned so far.
Electricity is used by all of us almost all the time. We use it for various reasons. Things that run on electricity have electric current pass through them. They are called electric appliances. A refrigerator, electric light bulb, electric fan, and washing machine are examples of
All the
electrical
consumers
appliances.
of electricity.
Most of the devices and machines we use, such as an electric iron,
This winter, explore 7 stunning glamping escapes across Odisha. Mornings by the sea, unwind by riversides,
oven, room heater, etc. work when an electric current flow through them. The common electric bulb is also called an incandescent bulb. Let's look at a transparent electric bulb. You will see a thin filament, that is, a very thin metal wire.
Closely observe. That is a
The
tungsten.
filament heats up when an
They are
electric
connected to
current is
copper.
passed through it. It heats up so much that it begins to glow and give out light. It is filled with an inert gas so that the filament does not burn up when it gets hot. Sources of electric current. A device that can be used to produce an electric current is called a source of electric current. Common sources of electric current are cells and batteries, and electric currents that we get from plug points in houses. A very
What are the
useful
sources?
kind of cell that we use very often is the dry cell.
Dry cell. They are
Due to a
called.
chemical reaction that takes place in cells and batteries, electric current is produced. Flowing water or steam is used for the large-scale generation of electricity. An electric cell produces electricity using the chemicals stored inside the cell. Let us look at the parts of a dry cell.
See
Each
how
cell
inside
has
you can
two
see.
terminals,
Inside the cell,
positive and negative.
top
The
positive.
cell
top
is
negative.
marked with plus and minus to indicate these
What kind of
terminals.
chemicals used?
Common uses of these types of cells: torch, remote, clock, etc. The dry cell contains dry or semi-solid ingredients. The dry cell consists of an outer covering made of zinc. Inside the zinc container, a paste of ammonium chloride is present.
There is a chemicals are inside the
Inside the
battery.
paste, a cardboard
They are
container
like
containing
cells.
powdered manganese dioxide is placed. The cardboard container has microscopic holes in it. Such materials are called porous materials, through which a chemical reaction takes place between ammonium chloride paste and powdered manganese dioxide. A rod, usually carbon, with the metal cap is
Carbon
dipped into the
rod.
manganese
To
dioxide.
break your car. Any cell you can find
The
everything.
whole thing is then sealed, with only the metal cap sticking out, so that the contents do not spill out. Advantages of a dry cell. They are easy to use in a simple electronic device. There is no worry about linkage in the dry cell.
Dry cell.
Dry cells are safe during transportation. They are small and lightweight.
So these are the advantage. Why you use the dry cell?
Different cells use different methods for producing
This is
electric
the
current.
button cells you use in the watch.
Primary cells can be used only once, and have to be thrown away once they have been used. There are cells that can be recharged once they are drained.
Rechargeable
These are
batteries.
called secondary cells. They are used in mobile.
See, there are two types of cells: primary, secondary. Primary cell can be one which can be used only one time. It may be 1 week, 10 days, 15 days, no matter. Once they stop working, we have to throw it out. But whereas there are secondary cells are there which are rechargeable cells. We can recharge them and we can use again and again, like lithium cylindrical cells, and so many are there.
Phones
6 volts, 9
Laptops.
volts.
and batteries.
They are all rechargeable.
Nowadays,
Laptop batteries
solar
and all.
cells are being used in many applications.
Pollution.
Solar
free
cells
solar
use sunlight to produce electric current. Many calculators are powered with solar cells. Solar panels made up of solar cells are used to light up streets and many homes. 3 basic conditions are required for an electric current to flow. A device such as a cell, a battery, or a plug point acts as a source, used to produce an electric current. A wire made of a metal such as copper, silver, or aluminum will allow electric current to flow through
Copper,
easily.
silver, aluminum.
An unbroken loop running from one terminal of the source through various appliances, back to the other terminal of the source. A cell is a single unit device that converts chemical energy into electric energy. A battery usually consists of a group of cells. A cell is usually light and compact as it has a single unit. The battery normally consists of several cells, thus giving it a bigger size and bulky look. A cell supplies power for a shorter period of time. A battery can supply power for long durations. A cell is used mostly for lighter tasks that require less energy. It is used in clocks, lamps, etc.
See the difference?
A battery is mostly used for heavy-duty tasks.
Automobiles.
It is used in automobiles,
Yes,
inverters,
self-start.
etc. Cells are usually cheap. Batteries are much costlier.
Right, that is the difference between the cells and batteries.
This winter, explore 7
Right.
stunning glamping escapes across
batteries.
Odisha.
An electric circuit is a path through which electric current flows.
See, that is a current
An
circuit.
electric switch is a device, usually electromechanical, used to open and close an electric circuit. This disables and enables the flow of electric current, respectively.
See, on off.
Difference
That is
between
for on-off.
closed and open circuit. An electric circuit in which there is a gap, or break, that disallows the flow of current is called an open circuit.
Disallow.
An
Means open circuit is the one when the switch is off. When you switch off, what happened? Current won't flow. That is called open circuit. No confusion. Open circuits disallow the flow of current. What is disallowing? That is switch off condition or disconnected. When wire is disconnected, that is called the open circuit. When circuit is closed, current will pass. Right?
electric circuit that has a closed loop through which current can flow is called a closed circuit. Open circuit represents the off state
Off.
of the circuit.
On.
Closed circuit represents the on state of the circuit. An open circuit is a discontinuous path. A closed circuit is a continuous path. In open circuit, the electric current cannot flow in the circuit, that is,
Current
current
is-
is zero. A definite current flows in the closed circuit. A common example of an open circuit is the circuit of a lamp with a switch in the off state. An example of a closed switch
Right.
is the circuit of a lamp with a switch in the on state.
So when current is not flowing, when you switch off current, that is called open circuit. When you on the switch, it is called closed circuit. In open circuit, no current will flow. In closed circuit, current will flow. Means open circuit, we cannot make the bulb to glow. But in open closed circuit, the current is flows through the cable and the bulb will glow or any other appliances will work.
A circuit diagram represents a
Symbolically
schematic representation of the components used in a circuit. Various symbols are used for each.
Pictorial diagram. You can see how nicely beautiful shown. Switch, battery, and bulb wire. Same. Switch is this, bulb is this, and battery is 9 volts battery connected here. So symbolic
Component
representation,
used in an
circuit diagram,
electric circuit.
and pictorial circuit diagram.
Look at the different symbols and their
See how
function.
symbols. These are the symbolic. How the wire is represented. Wire, straight wire only. Bulb, you can represent like this also. Not apart from that. Cell, one long line and one short line. Battery, combination of cells. More than one cell is called battery. Switch, see, it is opened. When it is placed directly here, it is a closed. That is symbolic representation.
Wire helps in the flow of current in the electric circuit and is made up of metal such as copper.
Wire.
Bulb converts electric current to light energy and heat energy. Cell source of current with positive and negative terminals. Battery
Combination.
source of electric energy and is made up of 2 or more cells.
2 or more cells.
Switch device used to make or break a circuit.
Make or break the circuit.
We
On or
use
off.
electric switches to
See.
turn on or turn off electrical devices and machines.
See,
An electric switch is a device that is used to open or close an electric circuit. When we open an electric circuit, the flow of electric current in the circuit stops, and when we close an electric
Observe
circuit,
carefully
an
here.
electric current flows through it.
here.
In an electric circuit, a switch is sometimes referred to as key.
So
The
we
key
call
is
it as a
represented by a
key
symbol.
also. The symbol of key, that is.
This winter explores 7 stunning glamping escapes across Odisha.
An electric torch has 1 or more
Torch.
dry cells inside it, which acts as the source. The cells are connected through a switch to a small bulb. When the switch is pushed to the on position, the circuit is complete, and the bulb glows.
Right.
When the
Inside-
switch is
inside
pushed
how
to
they
the
are
off
working.
position, the circuit is incomplete, and the light goes out. Conductors and insulators,
Already we have
a
seen.
material that allows electric current to pass through it, is called a conductor of electricity. All metals are conductors.
See, these many are.
A few non-metals such as graphite are also conductors.
See, copper, gold, steel, lemon juice. You can produce current from lemon juice also. Silver, seawater, because it contains salt.
of electricity.
All these are the
A
electric
material
conductors.
that does not allow electric current to pass through it is
Good.
called an insulator of electricity, such as a rubber band
See,
and plastic ruler. Examples are glass,
see, they does not allow electricity.
wood,
Wood,
pure water,
pure water also.
dry air, etc. Electricity can be very dangerous if electrical devices are not handled carefully. We should be aware that handling of electrical devices can lead to serious consequences. Never play with electrical wires and sockets. Your hands should always be dry when you touch electrical appliances, plugs, sockets, etc. Do not touch the metal pins of the plug when removing or putting in plugs into sockets. It is advisable to cover all plug points with insulation tapes if small children are around, so that they do not put their tiny little fingers into the holes of plug points. Electrical devices such as laptops and mobile phones should not be connected to an electrical socket for charging while using earphones.
Right. So, wonderful information is given about the complete what we learned till now. Everything is explained here, right? Total up to here explained. Only thing is, now we have to see about the resistance. So in next class when we meet, we'll discuss about resistance. What is the effect of resistance connected in series, connected in parallel, right? Series and connection, parallel connection, what is the effect to resistance? And few more symbols, which already you have seen, the symbols of various electrical components or electrical devices like galvanometer, ammeter, and finally we'll end with the electric circuit. So in next class, we can close this chapter so that we can have only one more chapter, last chapter to complete, which take 2 to 3 sessions. So by end of January, we are going to complete the total syllabus of 8 chapters, right? So that's all for today. Have a wonderful day, friends. Thank you, all of you. So thank you.